Hello everyone, I'm Manoj. Let's start with the project design FPGA prototype and performance comparison of a 16-bit 128 tap FIR filter implemented as two different cases, as a hardware accelerator on FPGA and as in software on Nios 2. And we'll be using Altera Quartus 13.0, Qsys Nios 2 SBT for Eclipse, Altera D1 board for this project. Let's start with the project. We'll create a new project. We'll get the project directory. In this 8 project Quartus software FIR, so we'll be first proceeding with the software approach. We'll be implementing the FIR filter on the Nios 2 processor using the C language, and we'll set this top level design entity as Qsys. I'll talk more about it later. Right now I don't have any of the Verilog files to be included in my project, as I'm using D1 board. I use model sim for simulation, and your Quartus 2 project is done. Okay, so project is created. Now we'll go to Qsys. Qsys is basically a system building software. You can just drag and drop your system components and join them to create a system. And for a system, we'll be needing a Nios 2 processor, because we'll be implementing a FIR filter on Nios 2 processor. We'll need on-chip memory. We'll need JTAG UART port for communication, and we'll also need a performance counter to evaluate the performance of our design. So let's start with Nios 2. This is the configuration window for Nios 2 processor. There are 3 types of Nios 2, and we'll use the economical version as it is sufficient for our requirement. As you can see, there's a clock module. This is the by default included in the design. This is basically a clock generator. We'll need on-chip memory. To be on safe side, I'll use 8192 bytes. We need JTAG UART port. It's good to go. Okay, so these are system peripherals. Oh, we forgot one. Performance counter. Okay, so now you all can see this is the clock generator module. This is the clock being generated. This is the reset being generated by the module. We need to give this clock and reset to all the other components of our system. So let's start with clock. We'll give it to Nios 2. We'll give it to on chip. We'll give it to JTAG performance counter. Similar way, we'll give the reset to Nios 2, on chip memory, JTAG performance counter. And you can see the Nios 2 processor. This is the data master, instruction master, Avalon protocol, memory mapped. So we need to connect these pins to the other peripherals. So instruction master is basically to fetch the instruction, and as you know, we'll be burning our code into the on-chip memory. So we need to connect this instruction master to the on-chip memory, and we only need to connect the data master to JTAG port and performance counter. And there are some interrupt pins that needs to be connected. Now at the downside, you can see a bunch of errors. This is because we haven't assigned base address to any of the component in the system. To assign the base address, just go to system and assign base addresses. So we are left with only 2 errors, and it is because we haven't specified yet the reset and exception vector of the Nios 2 processor. So this is the reset vector. We need to set it to on-chip memory, as we'll be using the on-chip memory for our code. Okay, so we are out of all the errors. Let's save the system. Project Qsys. If you guys remember, we give the same name to the top design entity while we created the project in Quartus. This is because when we will generate our system in Qsys, it will give a bunch of log files, and one of them will be the top file, and we'll have a top module, and that top module name will be this. And as we'll be using the same top module for our whole design, that's why I give the same name to the top module of the Quartus project. Save it. It's good to go, so we can generate the system. So on generating, we'll get all the Verilog files that we can import in a Quartus. Basically, Qsys will give you all the Verilog files and also a .qip file that resembles all the Verilog files. So you have two options. You can either import all the Verilog files in your Quartus project, or you can import just a .qip file in your Quartus project. Okay, it's generated. So let's go with the second option. We'll import only one file, that is .qip file, in our Quartus project. So if you guys want to see, this is the top Verilog file being generated by Qsys, and these are all the supporting Verilog files generated by Qsys. So if you want to import all these Verilog files, then you need to import this file and all the files in this folder. But for now, we'll import only one file, that is QIP file. This is a QIP file. So it is imported. The next task is to assign the pins. According to our system, all the modules being included in the system are into the FPGA chip. None of them is outside of the FPGA chip. So none of the IO pins are being used of the FPGA. The only pin of the FPGA being used is a clock pin, because the oscillator is outside of the FPGA and will be importing the clock. So we need to assign the pin for the clock. So let's assign the clock pin. It will be clock underscore clock. And the reason I'm writing clock underscore clock is because this is the name given to the clock. If you see the top design file, as I showed you just now, if you open it and you see, the top module will contain the clock with this name. For every pin you need to assign two things, that is a location and this IO standard. Location for the clock for this particular D1 board is pin underscore L1, and the standard we use is 3.3 TTL. Let's save the assignment editor, and we are good to compile our design. It may take a bit longer. By the time we can go to Nios. Let's go to Nios of SBT for Eclipse. Let's set the workspace. So we are using demo software folder for project. Inside that, we can create a software folder. So this software folder will include all the C files and all the Nios 2 libraries. So we get the software folder as a work directory. So this is your Nios. Let's see Quartus. Okay, so we have successfully compiled our design in Quartus. Now, upon successful compilation, Quartus will give you a .sof file that you need to burn into the board. So let's burn that SOF file into our D1 board. So this is the USB blaster. We are successfully connected to the board. We need to add the file. This is the .sof file. This is the same name as we give to the Qsys project. Okay, so successfully burned. We'll just save this .cdf file. Maybe as chain one. This is good. Okay, so the system is built into the board. Now we need to program the system for its proper execution. So this is our Nios 2. Let's create a new project in Nios 2. This is new. You need to create Nios 2 application and BSP from template. Qsys also gives you a .sopc info file. This is basically the info file which contains all the details of the system which Eclipse needs to program. As there is only one Nios 2 core in our system, so this is the CPU. Let's name our Nios project as Proj Nios software FIR, and let's set the default location. And here is the hello world template. There's some resolution problem, that's why you can't see the whole window, but there is one more template just down of the hello world. It is hello world small. So I'll use the hello world small template as I'm using on chip memory and it is limited, so I'll use a small template. Basically it compiles less libraries and occupies less space on the system. Okay, there's some problem with the project. For this, what you can face this problem many times during your project. So what you guys can do is you guys can create a new folder, software. Let's delete this file from disk. Let's create a new folder, new project, sorry. Let's import that sopc info file again. Now we'll set the project directory as a new folder we created just now. We'll choose this hello world small template. Okay, so we have successfully created the project, and you can see in the top folder there is hello world small.c. This is your main C file. It will contain the template for the hello world. This is your code. Now let's build this code. As we already built the system on the board using the .sof file, now if you want we can directly build this software onto the board. and that we can do using run as news to hardware. That we'll be doing next. So it is built successfully. Now we can run this code as news to hardware. So now we'll be running this code on the Nios 2 hardware, and we'll expect the hello from Nios 2 on the Nios 2 console here. Okay, so you guys can face this window. In this window you need to go to target connection, you need to refresh the connections, and you will see the new USB blaster. You need to apply. Just ignore the system ID and timestamp. Okay, so it is hello from Nios 2. So we established a connection successfully with the Nios 2 processor, and we are able to get the data from Nios 2. Now we will be implementing the FIR filter on Nios 2. I have a code for FIR filter. So this is my code for FIR filter. These are my input data values, the coefficients. I am starting my performance counter, and in between I return the code for FIR filter in this loop, and after that I'm stopping my performance counter and measuring the cycles being consumed during the FIR calculations. Now let's build this software onto the Nios 2 board. Now the one problem here is we haven't specified the performance counter yet. This is the old one I used in one of my previous project. So from Qsys you can see the base address for every component. So here you can see that the base address of performance counter is 5000 in hexadecimal. So we need to set 5000 here. Just save it and run as news to hardware. Here is the percentage of processing. You guys can see is 8% executed right now. Okay, so we are done with the FI filter implementation. You can see the FI filter output is minus 34, and the cycles consumed for this FI calculation is 173753. As you guys can see here, as it's printed, welcome to mini project 4 software implementation of a FIR filter. And this is what we printed at the end. Thank you guys. So we are done with the first part of our project. We'll be continuing the second part in the second part of this video. Thank you.